Okay, so today we're taking a look at the Cartesian plane and graphs of equations. We're going to look at a couple different things, the midpoint formula and the distance formula. Additionally, we're going to take a look at plotting some of these points just as a review of what that looks like. So example 1, let's look at part A. Let's plot these points 1, 3. So 1, 1, 2, 3. And 4, -3, I believe was the other one. 4, -3. So 1, 2, 3, 4, 1, 2, 3. And then we're going to draw a line in between them. So let's grab a line here. And we want to extend that line so that the line goes on forever in this direction and forever in this direction. So there's the line. We plotted the points, drew the line on there, took a look at those two things on the coordinate graph. Second thing, find the distance between them. Well, in order to find the distance between them, we need to use the distance formula. So here's the distance formula. Let's use it. All of the x's and y's that we're looking at are parts of a coordinate point. x1, y1 are parts of the first point, and x2, y2 are parts of the second point. Notice that in your reading, I put them the other way because it doesn't really matter. Okay? As long as the x2 and the y2 go together and the x1 and the y1 go together, it doesn't matter which is which. But I like to do x1, y1, x2, y2 because 1 goes before 2 in most cases. So let's take a look at it. We use distance formula d equals the square root of x2, which is a 4, minus x1, which is a 1, quantity squared, and then plus y2, which is -3, minus y1, which is 3, quantity squared. We've got the square root of 4 minus 1 is 3, quantity squared, plus -3 minus 3 is -6, quantity squared. 3 squared is 9, -6 squared is 36. 9 plus 36 is 45. And the square root of 45. This is where the extra Algebra 2 work comes in. And it's something that if you know a friend that's in Algebra 2, they're actually probably working on right now. So the square root of 45 can break down into the square root of 9 times the square root of 5. We want to find perfect squares that multiply to give us that 45. 9 times 5 gives us 45. The square root of 9 is a 3, and the square root of 5 gives us our answer. So 3 square roots of 5. That's the distance formula. The distance formula requires a lot of work. It goes through and does a lot with the square root, realizing how to rationalize and simplify that radical. And now let's take a look at the midpoint formula. Midpoint formula, we're going to use the same x1, y1, except the midpoint formula, we're going to use this equation, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and then those are both in parentheses. So the midpoint, we're looking at taking and really averaging the 2 points. So we're taking the average of the x's, the average of the y's, and we're finding the midpoint by doing that. And so we're going to use the same x1, y1, x2, y2. We've got parenthesis x1, which is 1, plus x2, which is 4 divided by 2. And then we've got y1, which is 3, plus a -3 divided by 2. 4 plus 1 is 5, so 5 halves is the first one. If you wanted to change that to 2.5, that's fine, but don't be afraid of fractions. And I do the next one, 3 plus -3 is 0. 0 divided by 2 is 0. So it should match up in the graph that I just drew, that I look about halfway between these 2 points is going to be about 5 halves, comma 0. And if I drew it properly, I can see that 5 halves, which is about 2.5, comma 0, which is right there, is going to be halfway between the first point and the second point, and it is. Okay, so the graph will give you an estimate of what that midpoint is actually going to look like. In terms of the distance here, it's a little bit harder to tell what the distance is when we look at it just on a graph, which is why we have the distance formula. All right, the second one, let's take a look again, plot the following points. So we're going to plot 3.2, comma, -5. So 3.2, 1, 2, 3, and a little bit more than that, comma, -5, 1, 2, 3, 4, 5, which is about right here. And the other one is 6.1, comma, 2.9. 6.1, 1, 2, 3, 4, 5. 6.1, comma, 2.9. 1, 2, and almost 3. Okay, so we're looking at those 2 points. When I go and draw the line in between them, and then extend that line, but we can again take an estimate of about what the midpoint should be. The midpoint between those two should be roughly maybe 5.5 maybe. 5.5, and then possibly at -2, so 5.5, comma, -2. So let's do the midpoint first on this one, even though it says distance for part B. Let's do part C first. So I've got x1, y1, x2, y2. X1 is 3.2 plus x2, which is 6.1 divided by 2, comma, y1, which is -5 plus 2.9 divided by 2. 3.2 plus 6.1 is 9.3 divided by 2. And -5 plus 2.9 is 2.1, -2.1 divided by 2. When I look at those two, I was about right, 9.3 divided by 2, so 9 divided by 2 is 4.5. So pretty close on that one. And then -2.1 divided by 2 is about a -1. Let's take a look at this graph again. So that says that the midpoint is about this point right here. So I was off a little bit when I was looking at it. I was thinking it was a little bit lower than that, but now that we did the midpoint formula, it actually looks like it's the midpoint. Let's go back and finish up this part B problem by completing the distance formula. We want to use the same x1, y1, x2, y2, which I partially erased, y2, and just do the distance formula. Equals the square root of x2, which is 6.1, minus x1, which is 3.2, quantity squared, plus y2, which was 2.9, minus -5, quantity squared as well. So we have the square root of 6.1 minus 3.2 is 2.9, quantity squared, plus 2.9 minus -5, minus a negative is plus, so 2.9 plus 5 is 7.9, quantity squared. When I add those two things together, I do the multiplying. 2.9 squared, I will pull out a calculator for, but I know that it's going to be close to 9. And I know that because 3 squared is 9, so 2.9 times 2.9 is 8.41. And 7.9 squared, 7.9 times 7.9 should be close to 64, and it is 62.41. So I'm going to add those two things together, and we get a 70.82. The square root of 70.82 is going to give us an 8.42 approximately. approximately 8.42. So the distance from between these 2 points, from here to here, up here, sorry, that didn't work, from, let's do this, from here to here, it is approximately 8.42 units. Okay, and finally the last one, you can go ahead and plot those 8, -2 and -5, -5. The next part finding the midpoint. The midpoint, by the way, if we write midpoint, we don't write it with an M. The M stands for slope, so if you're going to write midpoint, the closest abbreviation you can do is this. So again, we're going to do x1 and y1, x2 and y2. We do x1 plus x2, that's a 5, divided by 2, and y1 plus y2 divided by 2. 8 plus 5 plus -5 is 3 halves. -2 plus -5 is -7 halves. 3 halves you can write as a decimal, 1.5. -7 halves you can write as a decimal, -3.5. And that's the midpoint. Should match up with the graph that you had on the other side. And finally, the distance formula. Distance formula equals the square root of x2 minus x1, so -5 minus 8, quantity squared, plus y2, -5 minus y1, which is -2. -5 minus 8 gives us -13 squared, plus -5 minus a -2 is actually -3 squared. Squared didn't show up. -13 squared is a positive 169. -3 squared is a positive 9. 169 plus 9 is 178. Look at seeing if there's any perfect squares in 178. And there are not, because I can break down 178 into 2 times 89. 89 is going to give us a prime number, so we're good to go with the square root of 178 for the distance. Make sure that you can do the midpoint and distance formula and plot these points for your quiz.